Hi, my name is Heemin. I'm a design section leader for mixed signal products at Linear Technology. Today, I'll talk about our highest performance successive approximation register analog to digital converter, the LTC2379-18. The SAR ADC, which I co-designed, digitizes analog inputs to 18-bit resolution at 1.6 million samples per second, with no cycle latency while maintaining an unprecedented 101 dB of signal-to-noise ratio. This combination of accuracy, speed, and low noise makes the 2379 ideal for many demanding industrial, instrumentation, and automated test applications. I'm sure most of you are aware of how a basic SAR ADC performs, but I'll briefly go over the architecture to illustrate how we achieve such amazing performance. A successive approximation register ADC consists of three major components: a binary weighted capacitive digital to analog converter, or CDAC, some control logic, and a fast, very low noise comparator. The basic operation is straightforward. The CDAC generates a first approximation of the input voltage. The comparator checks to see if this approximation is below or above the input, and the control logic updates the CDAC to generate a closer approximation. As you can see, the voltage on the CDAC should converge towards the input voltage. You may then ask, what's so special about the LTC2379 that allows it to achieve unprecedented accuracy? As a co-designer of the LTC2379, I can tell you firsthand that we took unbelievable care in the design and layout of the CDAC and comparator. Furthermore, we applied patented circuit IP to achieve precision beyond the tolerances of the process technology. All in all, the extreme attention to detail, coupled with innovative circuit tricks, allowed us to achieve an unparalleled 101 dB SNR and an amazing 2 LSB INL limit at 18 bits in a tiny low-power solution. An important measure of an ADC's accuracy is its integral and differential nonlinearity, also known as INL and DNL. INL is the maximum deviation of the analog input to digital output transfer function from the ideal straight line characteristic. DNL is the maximum deviation in the difference between two consecutive transition points from the ideal value of 1 LSB. Both the INL and DNL are largely determined by the linearity and matching accuracy of the binary weighted capacitor array described in the previous slide. And as I mentioned earlier, great care was taken in the design and layout of the capacitor array, resulting in the terrific INL and DNL performance shown. Now I'd like to invite you into our lab, where you'll be able to see firsthand how we can demonstrate the 18-bit performance using our standard demo system. Here, I've connected a low noise, low distortion sine wave generator board to the ADC demo board, consisting of the LT6350 ADC driver, the LTC2379-18, and the LTC6655 low drift precision reference. The low jitter clock board provides the master clock to the system, while the USB capture board accumulates digital data from the ADC and transfers it to my PC. Now that everything is hooked up, let's see how the system performs. An FFT is a really useful way to measure the noise and distortion performance of an ADC. Here, you see the fundamental corresponding to the sine wave input from our generator board. Notice how low the distortion components are relative to the fundamental. Many of them are 130 dB or more below the fundamental. Also notice the SNR figure, which is approximately 100 dB. Taking into account the fact that we are driving the inputs at about 1 dB below full scale, we can see that the system really is achieving over 101 dB SNR with respect to full scale. Now I'd like to show you the INL and DNL performance of the LTC2379. I slightly modified our setup to capture a histogram of the ADC's conversion results so we can compute the linearity real time. This real-time approach really helps us understand the interaction between all of the components in this high-performance system, including the signal source, ADC driver, precision reference, and of course our 18-bit ADC. The INL-DNL performance integrates the effect of all of these components on the linearity of the overall system. As you can see, both the INL and DNL of the LTC2379 is incredibly flat and typically well within the guaranteed specs of 2 LSBs for INL and 1 LSB for DNL. In conclusion, the LTC2379-18 is a very high-performance 18-bit SAR ADC, designed to meet the challenges of your most demanding applications. For more information, visit us at linear.com. Thanks.